Hi guys, we're with the Geology Kitchen Dude again today. This video is a little bit longer, but I'm going to let the whole thing run. Make sure you're writing down the physical properties that are used to identify minerals, specific types of minerals. So there's 5 that he talks about specifically, and then watch, there's a screen towards the end of the video where he quickly mentions like 3 more. So you might want to pause the video while you write those down. So I think when you're all done, you'll have about 8 of them. Make sure you get them because you'll be using them to make some actual formal notes. So here you go. Enjoy.
We can find 5 properties of minerals that are diagnostic that will tell us what a mineral is. Just like fruit, there are a lot of different ways that we can describe a mineral. We can use a mineral's color, which just like a fruit, you pick up a red apple or a yellow lemon, it's kind of easy to figure out what fruit you're dealing with. But in the mineral world, the problem is that many minerals actually have multiple colors. So of all of the properties, color is the one you don't want to lean on as much. The second one, though, is the hardness of a mineral. And just like in some cases, like you've got this acorn squash here that's very hard, or this cantaloupe that's very hard, and you may have this peach over here which is very soft, minerals have different variations in their hardness. And in 1812, a German named Friedrich Mohs came up with a list of minerals that were ranked in order of hardness from 1 to 10. Like we call it the Mohs hardness scale. And each one of these minerals has a different hardness. A harder mineral will scratch a softer mineral. And we also have things like knife blades, pennies, and iron files or nails that we can use that have specific hardnesses of their own that we can actually physically scratch minerals to see, well, yes, it did scratch it, so it must be softer than a penny, or it must be softer than an iron file, or softer than a knife blade, and so on and so forth. And what it allows us to do is categorize the minerals based on relatively how hard or soft they are. That helps us to get to which mineral group that we're dealing with. But we really need more information than that. So the next step is to look at what we call the luster of a mineral. The luster of a mineral is basically how shiny a mineral is, or how light reflects off the surface of the mineral. And if I use fruit as an example, here you can see this apple is actually very shiny. Light reflects easily off of the surface of this apple. But the peach looks quite dull. And as light hits the peach, it gets diffused and absorbed, and it doesn't reflect back to your eye strongly. So we can look at minerals and classify them based on whether they're very shiny minerals and they reflect a lot of light, or if they're very dull minerals like this one that absorb light or let it pass through. Another thing that we can look at is the shape of the mineral. And just like when you see a lemon, you always know it's a lemon because it's got that goofy lemon shape. In crystals, because of the unique order that every mineral has in its crystalline structure, they have unique shapes. For example, this feldspar creates angles that we can identify and measure, or this selenite crystal, this gypsum crystal, you can see lines and angles. What we call that is cleavage. And every mineral breaks along weakness planes within the crystalline structure. And so we get unique shapes that form over and over again. So sort of like a fruit, we can look at the shapes that are produced by minerals and help identify which kind of mineral it is. Finally, we can think about the density of the minerals. Some minerals are very heavy and include ores of things like lead, which is a heavy metal. In other cases, we have minerals that are very light, again, like this piece of aragonite, which is quite light, or talc or gypsum. We can look at the relative density of the minerals and also categorize. So once we've figured out all these different properties, we can identify which set of properties belongs with which mineral. That helps us identify the name of that mineral and also the constituents within it.